Hello everyone, I am Someshri Dhanapati, Assistant Professor of Civil Engineering at Vedang Institute of Technology. In our previous classes, we have discussed while application of UDL and point load in case of simply supported beam. In this class, we will apply UVL in simply supported beam and will solve. So, first we need to draw the simply supported beam and let's apply UVL there. So, we know that in case of simply supported beam, there will be one end is going your hinge support and another end is your roller support. Okay, so let's name it as A and another point as B. So, let's apply the UVL. UVL is your uniformly varying load. So, this UVL is what? W. So, while solving any this type of simply supported beam or any type of beam, first we need to convert the supports into reaction forces. So, let's do that. And here are the reaction forces at point A and at point B. Okay. So, these reaction forces at point B as RB and reaction force at point A as RA. Okay. We can see this load is applying here in like a triangle shape or triangular shape load is applied here. So, this is your W and to calculate the total load, okay, to calculate the total load, we need to find out some formulas. The formula is nothing but your area of triangle. Okay, so area of triangle is what? Half into base into height, right? So this half into base into height we will put here. So this base is nothing but your total length of the beam. Let's take it as L. And this height is maximum height, we will take that as W. So the total load will be half into W into L, that is WL by 2. Now our work is to find out the reaction forces. The reaction force at point A will be what? In case of this triangular shape, we know in previously we know that while we equalize these forces at some point, in case of triangular structure, the midpoint, this point will be what? One point is 2L by 3 and another will be your L by 3, right? One is your 2L by 3 and another point is your L by 3. So, to find out RA, let's put the total load WL by 2 into the further distance, that is L by 3 divided by the total length. Okay. So, it is going to be WL square by 6 into 1 by L. So, here WL by 6 is your reaction at A. Next, reaction at B will be WL by 2 into 2L by 3 by total length. So, here it is going to be these two cancel, WL square by 3 into 1 by L, that is WL by 3. Okay. So, now we have the reaction forces, that is Ra is equal to WL by 6 and reaction force at B is equal to WL by 3. As we have the reaction forces, next work is to find out the shear forces. Okay, so to find out shear force. To find out shear force, we need the diagram. Let's draw it here. Here are the reaction forces and the application of UVL. Okay. So, to draw SFT, we need to just increase these supports, right? Now, these are your reaction forces. Okay. Now how to calculate shear force? Before going for the calculation, we just need to cut the beam with section XX. Okay. And here, this is your A, B, and let's take it as C. And let's this distance take it as X. Right? So, to find out shear force at XX section, first what? Your reaction force, we know that reaction force at A will be WL by 6. WL by 6 minus here, the force acting in this section. How to find out? So, let's take the area first. The area will be half into what? W x by L into the distance, that is your x. Okay. So, here we have the equation for shear force. So, by 2L. Right? Next, now as we have the equation, we can find out shear force at any point. So, shear force at point A and at point B, we will calculate. So, at point A, shear force is, so you can see at point A, this x is going to be a 0. So, here WL by 6 minus 0. So, shear force at A is going to be WL by 6. Right? Next what? At point B. So, at point B, you can remember that we have taken this distance as L. As we are taking from left side, so this total length is L. So, shear force will be WL by 6 minus this x is going to be L minus W L square by 2L. Here cancel. So, WL by 6 minus WL by 2. 6 WL minus what? 3 WL. That is going to be minus 2 WL by 6, and we are having minus WL by 3. So, shear force at point B, we can write SF at B is what? Minus WL by 3. So, here we are having the shear force at point A, that is WL by 6, and at point B, that is what? Minus WL by 3, right? So, you can remember, while application of UVL in case of simply supported beam, there will be the structure is going to be square parabola. So, our structure is going to be like this. Here is our SFD. Suppose diagram. So, you can see at point X, here the shear force is 0. There will be one thing I need to tell now, that while you can remember, while shear force is 0, bending moment is maximum. At any structure or at any point, you need to remember that when shear force is going to be 0, then bending moment is maximum. So, in this point, we will have bending moment, that will be maximum bending moment. Okay. To find out the maximum bending moment, we need to find out what? The value of x. So, how to find out the value of x? Now, to find out value of x. Okay. So, to find out value of x, we need to go for what? This shear force equation. Here we have the shear force equation. Let's go for it. WL by 6 minus WX square by 2L. Minus what? WL by 6 minus WX square by 2L. Let's take it as 0. Because shear force at that point is 0. Okay. So, we can write WL by 6 is what? WX square by 2L. Sorry. This W and W will be cancel out, and here 2L square by 6 is equal to your x square. We can write x square as L square upon 3. Let's x is equal to x by root 3. Okay. Now we have the value, that is here in this diagram. These to this diagram we are having, that is L by root 3. Okay. So, now we have all the values of shear force and shear force. Let's go for bending moment. To find out bending moment, what we need? We have already known that what? Bending moment is nothing but your shear force or force into perpendicular distance. So, Here let's take the beam. To draw the BMD, we need this. Okay. We already have found out the shear force. Okay. So now our work is to find out bending moment, and here is the section XX. Let's name it as C. So we know this point we will have maximum bending moment, right? So how to find out? We just need to remember that as we are having our shear forces. So here we have the shear force equation. We just need to do what? We just need to do the perpendicular distance with, we just multiply perpendicular distance with this force and with this force. Okay, these are the nothing but what? One is this RA and another one is the load acting here. So we just multiply the perpendicular distance and we will get the bending moment value. So here we know this RA is equal to WL by 6. Bending moment at X. What? WL by 6 into your distance. So, distance is what? X. Okay. As we are finding out about this triangle and the distance, we know what? X. So, here the section will be cut at some point, and one point is going to be x by 3 and another one is going to be your 2x by 3, right? So, this is your WL by 6 into x. While we equalize the forces at some midpoint, then we will have these values, right? So, next is minus what? Wx square by 2l. Wx square by 2l into x by 3. Okay. Let's this as 2x by 3 and here x by 3. Okay. So, WL by 6. Let's put the value of x. WL by 6 into L by root 3 minus W by 2L square into what? L by root 3 into 1 by 3. Now, WL square by 6 root 3 minus W L square 2L into root into 3. Multiply with L by 3 root 3, right? So now we are having the equation that is WL square by 6 root 3 minus this L with this cancel, WL square by 2 into 3, 6 into 3, 18 root 3. Okay. Now 3 WL square minus WL square upon 18 root 3, and we are having 2 WL square by 18 root 3. So, this 2 you cancel. So, WL square by 9 root 3 is your maximum bending moment. But WL square by 9 root 3. This is your bending moment at point C. Let's find out bending moment at point A. So, at point A, okay, at point A, what will happen? Here, in this x value is going to be your, at point A, this x is going to be 0. So, bending moment at A is 0. Then bending moment at B, we need to put the value of x as L, right? So, WL by 6 into L minus W by 2L into L square into L by 3. L cancel. Now, WL square by 6 minus WL square by 6. Also, bending moment at B is 0. So, at both the supports we are having bending moment 0, here also 0. So, you need to remember that bending moment diagram for while application of UVL in case of simply supported beam is your cubic parabola. Okay. Drawing is going to be like this. Here at point C, we are having WL square by 9 root 3. You can remember that in this point, shear force is 0. So, here we are having this our bending moment diagram, and here is our shear force diagram. So, in this class we have learned about how to find out SFD and BMD in case of while application of UVL in simply supported beam. So, UVL will be applied like different kinds, like this also we can apply UVL. So, in our next class we will discuss some another type of application of load in case of any type of beam. So, to know those things you need to stay tuned. Thank you so much.